Hey, welcome to Guru session number 13 about depth map cameras and tracking and using Isadora to sense the motion of a human being. Thank you for being here. I'm sorry about my mistake making the video private at the beginning. Forgive me. I'm still a newbie. I'm not a YouTube star quite yet, I guess. So first things first, if you haven't already, scroll to the top of the chat and make sure to download today's session materials. It's a big file. It's 500 megabytes because there's some big media and there's new versions of the plugins in there. And so you should get that, okay? And just a status report. I had hoped that maybe I would finish getting Kinect version 2 working with this plugin, the OpenNI tracking plugin, for the session today. I didn't quite make it. I am hoping that next week, which would be around May 15th, that I will have it working. It's very close. It actually works on the PC, but I could not perfect it on Macintosh, and I need them both to work and be the same before I put them out, even as an alpha. So that's where we are today. We're going to be using either, if you're going to use an actual depth map camera, you're going to need to have a Kinect version 1 or a Orbbec Astra or an Intel Realsense D435, okay? The thing is, though, as we've talked about on the forum and in the tutorial for this actor, the Intel isn't so great for actually doing body tracking. The algorithm doesn't respond well to its image, but it has some other interesting properties just for doing depth maps, which is something we won't get deeply into today, but it does have advantages in certain situations, okay? All right, so we're going to dig in, and what I'm going to do, because that file is really big, I'm going to talk for a little while and make sure that you've got that download, because it might take a moment, to get it. And that's okay, because I want to go through a couple of other things first anyway, right? So what I want to do is I want to call your attention. Let me call this up here. I want to call your attention that on our plugins page at Troikatronics, you will find this is actually in the download. You don't have to download it again, but I just want you all to know that it's there. So here is this. So this is the tutorial that you can download right now, and I'll put that link in the chat window right now so you have it. But you don't need to download it again because it's in the file you're downloading that is at the top of the chat. But this tutorial is actually a great starting point, especially if you're absolutely new to this kind of technology. Here, let me let you see what I'm talking about here. This is the page that we're talking about. There. That's the page on our plugins page, right, where you can download this tutorial. That's really important, especially if you're a teacher, because it really goes through all the beginning steps that you need to make sure that you're going to be able to succeed using this new plugin, right? So make sure that you know about that and keep track of it. So that's the tutorial. But like I said, you're getting that file. So I'm going to close this now, and hopefully I'm going to be able to go in here. And I'm going to even unzip it right now, and I'm going to open that tutorial. Okay, so here's the thing. I don't know where everybody is at in terms of how much they've worked with these cameras, if they're at the beginning or if they're totally experts. So what I'm going to do, I'm not going to go through every single thing in this tutorial. That wouldn't make a lot of sense. But I think it's good to hit on the main points of it so you know what's in there. What I want to show today is how to use these devices in an artistic way. I think I've made some interesting patches for you to look at. Yeah? And I'm going to get my face off of that screen now. You're going to just see the screen because there's a lot of windows there. Yeah, so let's just take a brief look at this tutorial, and again, you're just going to see what the contents are, but go back if you're new to this kind of stuff, down and open this tutorial and go through it with care, okay? So there's just an intro screen there. I'm just going to kind of zip through this quickly, but to point out some of the most important points, right? And, oh, I need to unload the other file. Okay, good. All right, so you got to get the plugins, and we're going to do that today because there's one little new feature in there that I think some of you who've already used this will be excited about. You don't have to do that either. You just downloaded them in the big download. So you've got to get them and install them, right? And so then we just introduce the actor. And then we talk about the cameras we support, right? The Kinect model V1, model 1414, and model 1474, the Orbbec Astra, the Intel Realsense D35, and then the Kinect V2, as I was talking about at the top of the show here. So I'm close. Stick with me, check in the forum. I'm going to be announcing something quickly, I think, about the Kinect V2. I saw it. I saw the image myself. I tracked someone with it. It does something. Okay. So, but then one important thing is you need to make sure that you've got the right model Kinect. There's actually more than just the two I mentioned. There's a few other ones out there, and this section tells you how to identify to make sure you've got one that's going to work with our plugin, yeah? Okay. And then just some quick tips that if you don't know them already, the original old Kinect requires a separate, or both versions of the Kinect require a separate power supply. That's pretty obvious on the Kinect V2. It's a big beefy thing, but it's not so obvious on the Kinect V1 because the connector kind of looks like a USB connector, but it's not. And you need this power supply, otherwise you can't, you won't be able to plug it into your computer, right? You really shouldn't run these things through a USB hub. You have to really avoid that. You really should be plugging it directly into your computers. And finally, you can use USB extensions. I've done it if you need them to be further away, but they have to be active. And yes, the 1517 does not work, unfortunately. That is not a model that I have been able, it's just not something that's supported by these things, okay? But USB extensions, they have to be active and no more than 5 meters or 15 feet, okay? So now it actually goes into the part where we're going to make a connection. I already have my Kinect V1 plugged in over there. I don't actually have the other cameras with me. They're being shipped to me as we speak. They're in lockdown in a different city than me, right? So what we're going to do is we're just going to jump in and try to connect, right? So I'm going to go here, and the first thing this tutorial does is, do you see an image? And there is the living room, right? Because, of course, all pieces are being made in homes and houses and not in theaters, right? So we're right on target with that. If there's no connection, it asks you to go back a step and gives you some suggestions, right? Now, what I can't do today, unfortunately, is if it's not working for you, if the camera isn't showing up or working, I can't address those individually because there's a lot of you over there, right? What I would suggest is let's just go through this today, follow along. Remember, you can always come back and watch this video later, and probably that's a good idea because some of you may not have someone that you can actually help you. You need someone to work with. That's one of the things that I have some good news about today, but it's helpful to have someone that can be in the camera while you're trying this, right? So if you're having trouble getting it working, then just come into the forum tomorrow or later tonight or whenever and let us know and we will give you help. And by the way, one of the things, because I'm not an expert YouTube person, I forgot to do, I'm supposed to say at the beginning to ask you to subscribe if you haven't subscribed to our channel, and and to also join our social media channels. This is like, it's a big effort that we're making to help get Isadora out there through these sessions and other things that we're doing. So if you do that stuff, it actually really helps us and it helps the software grow and stick around, yeah? So thank you for your support in doing that. Okay, I did that part. All right. And so my Kinect's working, so that's cool. And then the rest of the tutorial just guides you through some basic principles about this, but let's actually take a look at that. So again, if you're new to this, I'm just gonna do this really briefly. Take time, go back through this tutorial and actually really look at it. I think it's a good idea. But what the depth map image shows you is it uses brightness to tell you how far away something is, right? So you can see that the brightest thing is actually the closest part of the floor there, but you can also vaguely see the outline of the couch, and you can sort of see that lamp there that's in the corner, right? That's just on the right side of the couch, right? So, but you can even see some gradation in the wall because it's sort of a little bit tilted in relationship to to the camera, right? So that's what the depth map image is. And in a moment, I'm going to have my dear partner come in, and she's not a performer, she's an animator, but she's still going to be very brave and come in and be in the camera with us. So maybe you can come in there and you can just let us meet you. There she is, all in red. So the red thing, that's telling us that it is actually attempting to track her skeleton right now, right? We actually, I don't see a skeleton yet. I'm not quite sure why. Let's see. Maybe if she walks out and walks in one more time. Back up a little bit. All right, well, let's just keep going. So it's seeing that there is one body in there, and that's that red outline is telling us it's identified her as a body, right? So it can also do more than one. Now, I have to run away from the microphone for 1 second, but I'll join any. Yeah? So I'm the green person, right? I'm the second person in there. So when you see those multiple colors, that's actually telling you that the Kinect is tracking more than one person at a time, right? Okay. So, that means that it's working, right? And that colored image is telling us that it's seeing that as a body. Now, okay, I had the skeleton tracking turned off in the other one. So when you're tracking a body, there is an output here, if you look, if I zoom in over here, that says bodies, and it says 1 because it's just the one person in there. And you see the skeleton, it's trying to track any, doing an okay job. If she squatted down like that a second ago, it got a little confused. You can try that again. Yeah, it doesn't like that too much when you get too out of shape, right? So, that's one of the things about these systems. They have limitations, right? They don't always track perfectly. If you're in kind of a normal configuration, then you will probably be fine. But as soon as you start, twisting your body around, it can get confused. But as you can see, it's tracking. We see a skeleton. It's doing what it's supposed to do. To answer John Rogers' question, yes, it's going to be working very soon. I talked about it at the beginning of the session, okay? Next week, hopefully. All right, so, okay, and so now we know how many bodies we're tracking. We can see the skeleton is in there, and it all seems to be working, right? So let's go on to the next one. Now, one thing you have to understand is like these colors, right? You saw me jump in a minute ago, and I was green. That's because I was body number 2, because actually these colors tell you the kind of number or the identity that the system has about this body, right? Red is number 1, green is number 2, blue is 3, yellow is 4, cyan 5, etc. You see it there on the screen here. I'll just zoom into that just so you make sure you see it. Yeah, okay. So anyway, you'll go through this in the tutorial, but later you're going to want to know that if you actually try to track more than one body, then you're gonna need to know this information. Today we're only going to work with one. We're not going to work with multiple bodies today, and so just keep that in mind. And that table is there for you to reference later. Yeah. Okay. So, but one thing you can do is if you only want to track one person, then it's really helpful to actually set the maximum number of bodies to 1. Yeah, that's because it won't try to do more than one, because sometimes it can, on some occasions, become confused, and even an inanimate object, it will think it's a body, right? So it's best if you know you only have one body, then you will set the max bodies input that I just showed you to 1. Notice that also these skeleton outputs, which we're going to be coming to in a second, 2, 3, 4, 5, and 6 say NA and they're gray. That means that they're not available because you have said, I only want to track one skeleton, right? So therefore, it's not going to allow you to use the other ones, yeah? And then there's one thing that's important too, is that when bodies leave the frame, okay? Right now, there's a setting that says body lost mode. It's set to immediate. But I'm actually going to change that. I'm going to change it when lost. Now watch what happens. Annie is going to exit the frame here completely. So there she goes. And you'll see the skeleton. Well, it didn't linger, but it sometimes will linger over there. She's going to come back in now. Okay, there it is. And dash out of the frame one more time. No, it's still, sometimes you'll see it actually hugging the edge of the frame there. But the thing that's the advantage about that, you'll see that when she runs back in, it immediately finds her, right? But when you're doing a public, like an installation piece, where you just kind of want to know where the people are, and you're not even worried about their skeleton, right? Then you want to set that mode not to when lost, but to immediately. Because as people pass in and out of the frame, you want it to lose the person that walked out and get the person that walked in, right? Oh, there you can see the skeleton was just on the edge of the frame there. All right, so that's about bodies that leave the frame. That setting is actually really important, and if you're doing a public installation, it's almost certain that you're going to want to set that to immediately, okay? All right. So what's a skeleton? Well, I guess that's really pretty obvious. You can see it there in front of you, but actually not really, because you're seeing a two-dimensional representation of a skeleton, right? Because in fact, those points exist in 3 dimensions. They come to us through the actor, and they're given in 3-dimensional coordinates: X across, Y up and down, and Z towards us and away from us, right? So that's what we need to do. So you've got this skeleton over here, and we've got it connected, and you see here, here's a really big actor called the Skeleton Decoder. It's really big because we're showing all 15 possible points on the skeleton. And you see here that it starts with torso, left hand, left foot, right foot, etc. Right? It goes down the list here. And there you see the actual 3D points, X, Y, and Z, for every point that is being tracked. So let's zoom in just for a second on the torso one. Right now it says that's in millimeters, right? So it says 160 on the X. Now, what I'm going to have Annie do is walk to the left or to the right. You can't see her in the frame, but I just want to have you watch the number. See, it just got bigger because she walked to my right, and now it's getting negative because she walked to my left. That's just the X component of the torso, the center of the body, right? So these numbers are what tell you where the points are in space. Now let me take a quick pause. There's some questions coming up, just so I'm clear. That's awesome, because I could never get the skeleton to work for the Mac. I'm glad that it works for you. Yes, and keep in mind, someone had a crash. This is an alpha plugin. There should have been a beautiful document opened up saying that this is in beta. There are a couple of things that we are still working out with this. Part of what you have to understand is there is a whole lot of code in here that I did not write. This is the same code that many different softwares have used to do this tracking, processing, OpenNI. None of us wrote that code. It all came from somewhere else, right? So that's OpenNI, this open source system. And there's not, there's stuff going on there that we can't always control, right? So in any case, we do the best we can. We are trying to make this as stable as possible. We want to have you people use this and know that it's going to work, but there's some hurdles that we have to face. We are still actively working on that, and we're going to try and get it as perfect as we can. So, but it is a beta plugin, and we know there's some known crashes. You can see it in the beta document. We try to be as transparent about that as possible, because we don't want you to rely on something that we don't say is finished, right? Okay. My Kinect is working, but the beta actor is different from yours in the example. Well, there's a plugin that I have given you in the download. I didn't want to take the time to do it right this second, but we may take a small pause in a moment to allow you to do it, because I think you'll need it for the next section, okay? It would be great if we could record the skeleton image. Yes, Bone Map, that would be really great. I wonder, Bone Map, what this file and play and stop inputs that have appeared there on the actor could be. Well, maybe we're going to find out in a few minutes. Okay, so, and Annie, they're saying that you're a great performer. Thank you for being with us today. All right, so that's what a skeleton is. It's a set of 3D points. We have the skeleton decoder not just for this actor, but also for our actor that tracks the, I blanked. The name of the suit, the capture suit that...
The roll call
The Rococo, yes, the Rococo Smart Suit. We have an actor that will work with that device, which is a wireless, markerless capture system. It also uses the skeleton decoder. So all of these actors that provide a skeleton use this other actor to send the data out. And it has 19 points, not 15. You can have as many as you want. Okay. And there is a visualization of a skeleton. So I made an actor that is not really for making art, although someone probably will, because I always say this is just for testing, and then someone makes something beautiful with it. So this is the skeleton visualizer. This is just a little set of balls there. You can see up in the upper left what Annie is doing, and then you see the representation there. And if you click these little snapshots, there's the Michelin Man version where it's the same thing, but the spheres are a bit bigger. This one is like just some little squares, but I actually ran that through a motion blur actor to just give it a little bit more pizzazz, as we say in English. Here's one that's some big planes moving, and I think this is kind of an interesting abstract representation of the body. Yeah? Here's another one with some squares that's a little bit different, and another one. So the skeleton visualizer, probably you're going to end up doing something like that because it's going to help you see what's going on with the skeleton, right? But you don't have to if you want to muck around with some of the settings like you've seen here and turn this and run it, because it does have a video output. You can run it through all kinds of video processing actors if you want, right? All right. Okay. Wondering what would valid frames mean on status. I'm not sure what you mean by that question. You may need to rephrase it so I know what you're talking about. All right. That's just the skeleton visualizer. Valid frame. You mean on the status? You mean on the status output here? I'm not sure what you're talking about, I guess. All right, I'm going to continue until that gets clarified. Okay, here's a really nice plugin, though, that I did. This was in response to a question BoneMap asked on the forum. He was trying to create puppets, and it actually wasn't very easy. And so here you can see a wonderful, very simple 3D puppet. It's nothing fancy. It's just these little cones here. And Annie is moving around for us. You can see that it's following her pretty well. This required creating a little JavaScript addition to be able to do some kind of complex math, and it's inside of a user actor. But basically, this Puppet 2 segments user actor, if you give it you select 2 points that you would like to work with, it will just rotate this 3D model in the right way to make it create this puppet. So that's just kind of a proof of concept. I'm sure you could make something far more interesting and artistic with that with a little bit of work. But in any case, that's a nice example that's in that demo. Yeah. And then let's just dig in a little bit more to so here's about the skeleton decoder, right? As I said, it gives you access to the various points in the skeleton, right? So here's that big actor, which you may not want to work with because maybe you just need a few, right? So, but what's important here is if you open the whole thing up to 15, you see these names, right? It's pretty obvious. Torso, left hand, right hand, left foot, head, left shoulder, left elbow, etc., right? You see those names because that's actually really helpful, because the skeleton decoder, you can use this point cell input to be able to access any point in the list without having this giant actor, okay? So here's that. So here you can see a shorter skeleton decoder with 3 outputs, and in the point select, I have entered torso, comma, left space knee, comma, right space hip. And because I did that in that point select, those are the actual numbers that are coming out of that skeleton decoder, right? So, so that's why what that point cell thing is, because this can be so many numbers that you're dealing with. If you just need the left foot and you don't want to have to open up the list to get it, you can just type left foot and you'll get that one. So for example, if I do skeleton decoder, notice that the joints don't have names until I actually connect it to something. That's because every tracker could be different. So the default, if you have one input, is the torso. But here, if for instance I needed the left knee, I could type left knee in the point select, and now I'm getting the left knee instead, right? That's what that point select actor does for you. That's a super important one to know about. And it's telling you that there's a list of all those names in the folder of this tutorial, so you don't even have to remember it. It's there for you, yeah? And then, so here we're using the skeleton decoder, and we're doing, I'm not going to go through this right now because we're about to do it again in the new tutorial, right? This one is measuring the distance between her hands, but there's just a number, but let's just have her do that. So you can see it's now, 45 centimeters, and is that, yeah, 45 centimeters about. And now she opens up her arms, and you'll see it gets bigger and bigger and bigger. Now it's 168 centimeters. So this actor, the Calc Angle 3D, takes two 3D points, and it measures, among other things, the distance between them. And so here I'm just typing it out as a text. That's very boring. In the next tutorial, when today's real thing, when we get to the meat of today, you'll see that more, okay? But here's just one simple example. She's got oh, that's a bit loud. Let's turn that down. She's got a sine wave. So she's controlling the volume of that sine wave with her hands. All right? So, all right. That's just a simple example of using the distance between the hands. We're going to do more today. You're going to see some nice examples, I think, okay? All right, why don't you have just rest for a second, and I'm going to leave that scene because I need to look at all the questions here. And, oops. All right, there's some questions. Yes, even I had a small crash, okay, when I left the scene. Wondering what valid frames means on status. I really don't understand that question still. Bone map. The record is not totally finished. It works on Mac OS. It doesn't work on Windows yet. Obviously, well, you'll see it obviously worked because you're about to play some files that I recorded with it, but I needed to work on both platforms. Again, I think by next week I'm going to have all this stuff working. But at least you can play them, so we're closer. What happens to the cone puppet when Annie makes a shape that the sensor doesn't recognize when she sits in the lotus? Basically, what you saw before, whatever you see that white outline doing, that's what the puppet is going to do. It's not smart enough to recognize that it's a posture that is not being understood by the system. So, and let me go back to where you can see me actually. It's not going to know that it's just going to do whatever numbers you give it. That's the shape that it's going to make. So that's what you're going to get. Let's see. All right, going through. Okay, that's cool. Yes, it is cool. There's some cool things going on. All right. So now, here is where you would want to quit Isadora, yeah, and install. Well, no, don't quit yet. I forgot. Before you quit, go to the Help menu and say Open Plugin Folder, Troikatronics Actor Plugins. You want to open this, yeah? Okay, that's where the plugins live. Now you can quit Isadora. So, again, I should have done it slowly. Make sure you do it with me. Go to the Help menu in Isadora. You couldn't see my screen, could you? No, you couldn't. I better do that again. Oh dear. Here we go. Here's me and Isadora. So we'll do this one more time, just briefly. Open up Isadora. And Help menu. Open Plugin Folder. Troikatronics Actor Plugins. And when you choose that, it opens this folder. Now you can quit Isadora. And then in your Guru 13 folder, there is the OpenNI Tracker plugin and the OpenNI Tracker tutorial. Well, what you want is the plugin. On Windows, it's just a zip file. You'll just double click it and you'll grab this out of that. On Mac OS, it's a disk image. And so if I open that, you just need to grab the Izzy plug, all the ones that say Izzy plug, because those are the plugins. And you select those and you say copy 3 items. And then you go to the Isadora plugins folder and you paste. I'm not going to do that because I don't want to mess anything up that's working for me, but I hope that it should work for you fine. I'm hopeful, right? All right. So everyone take the time to do that, to install these, because hopefully this nifty new feature I made, and you'll, which is to be able to record the depth stream and play it back. Okay. So I'm just going to kill a little bit of time while you install those plugins. Let me just say that I'm really happy to be working on this because, as some of you know, the whole reason Isadora exists is because in 1989, I made a piece where I invented a device called the MIDI dancer that allowed me to measure the movements of a dancer wirelessly using these bend sensors and a wireless transmitter. It was all made out of radio control car transmitters I hacked. And it actually worked, and that launched off a career of exploring interactive tools and things like that. And so here we are still today thinking of ways to use Isadora to track performers. And what I wanted to do, I went through that tutorial really fast. Sit down and go through it slowly, especially if you're new to this stuff. It'll help you understand what's going on. But what I wanted to show today was some things about using Isadora in a kind of more beautiful, artistic way to give you some ideas, but also to teach you how it works, yeah? Okay, I'm going to assume you have that plugin installed and you've restarted Isadora and you've opened this file, the same one I have, Guru 13 Tracking with OpenNI Tracker, yeah? Okay, and I think I'll make my preview just a little bit bigger, yeah? Just so you can see the image a little bit more. I think you can see me, and I promise I will not hide the scenes like I did the other day. All right, so we're in the scene called Blackout. You can follow along, but I'm going to have Annie come back in now, and I'm going to have her demonstrate it live. Well, actually, before you do that, let me just show you what I've been talking about. Let's go into this scene, if it will let me. What did I do wrong? Okay, I did something wrong. One more time. Okay, OBS scene. All right, so as I said, many people have been asking to record the depth stream so they can play it back because it makes it much, much easier if you can actually work with a file instead of making someone dance around for you all the time. I have not totally completed it, but it's closer. And if you all hit the letter P, I hope it won't crash. This is so alpha, it's not even funny. But if you hit letter P, you should be playing a file that has any walking backward and forward. What do you think, folks? Tell me in the feedback. I know I'm delayed, so let's see if it's working. But you should have a file that is now, instead of your camera, it's playing the file. And I recorded that earlier today using this new feature where you can record the file. But I took the record trigger away because it wasn't working on Windows. It was working on Mac, but not on Windows totally. And I didn't want to give you something that wasn't working on both things, at least basically, right? So that's very close, as you can see. So let me know if you can see the file playing. I hope that you can, right? But I think it's nicer to have a live person, so now I'm going to hit the stop button, and then it's going to go back and find my Kinect, and then I'm going to invite Annie to come back in now. Yay! Everybody says it's working! Hooray! All right, so here's Annie back. That's the real one. That's the live one, although you'd never know necessarily, right? All right. Yeah. So, oh, yeah, that's true. She is a different silhouette. So, all right. So, now, what we've done in this patch is really simple. Let's look at this. I'm measuring the torso, and I'm using the Z position Okay, we'll talk about the limit scale value in a second, but I'm basically turning that into a range that goes from 0 to 100, and then I take that through a smoother actor into the position of this movie that Annie filmed also today. This is a cathedral on the banks of the Danube River here in Vienna. And so what's happening is, as she walks towards the camera, if you walk towards the camera, it goes back, it goes away from the cathedral. Step a little bit to the left so we can see the cathedral. There we go. Now, if you back up again towards the couch, right? So you can see that it's scrubbing the movie so that it just goes forward and backwards based on her position towards or away from the camera, right? Okay, so how did we figure that out? Well, what I had Annie do was that she was over by the couch there, as far as she can go away from the camera. You can be in the center though. Yeah, and I took a look at the Z position, and it was minus 3.3. Okay, so I set the to the limit scale value actor that we're using. I set the limit max to minus 3. And I set the limit min, walk forward. And I'm still looking at torso Z a little bit more. Yeah, okay, so the minimum was 0.9. You can back away now. So I set the limit min to minus 0.9 and the limit max to minus 3 because that was the measured range, right? That was as far as she could go, forward and backward. And then we're scaling that to 100 to 0. We inverted it because it made the movie, we wanted the cathedral to get further away as she walked closer, right? So basically, we had to do a calibration, and that's something you always have to do with sensors. You have to do some kind of calibration. You need to know what the lowest number is and the biggest number is so that you can convert that into a useful number, right? In this case, the useful number, we needed the position to go from 0 to 100, right? And so we needed to measure the furthest away she was and the closest. We used those for the limit min and limit max of the limit scale value actor. And then we set 100 and 0. I could have done 100 like this, 0 and 100. And now you'll see that when she walks towards us, if you go a little bit off center, they can see the cathedral. Now the cathedral comes close when she is close. So we reverse the relationship, right? But we just thought it was nicer if it went the other way. Okay? Okay. So to add one element to this, another thing I measured was how far she was going left and right. I'm not going to do it again in front of you, but I can tell you that it was minus 1 meter. Oh, someone asked in the chat a minute ago about the units. It was nicer to work in meters for this one. The skeleton scale input can be set to meters, centimeters, or millimeters. So you can choose which you like, and then it will affect, though, all of the numbers that are being sent out of the skeleton decoder, right? Okay, so I wanted to use meters. So basically, she can move left and right 1 meter. And I took that into another limit scale value that I limited to minus 35 to plus 35. And I'm now going to do this. You should join me in connecting the output of the second limit scale value to the rotate Y input of the projector over there to the right, okay? I'm just going to read the questions while you do that. Yes, I answered the question about the measurement in units. Okay. Okay. All right. So now, when any moves left and right, let's see. Can I go full screen with this? Let's see. Yes. So you can see that the image rotates based on her position so that the image kind of follows her. So she can move towards the camera and away, but the image is always kind of rotating to follow her. And it's pretty funny with the virtual red person there, how kind of strangely real it looks in a way, right? Okay, so that's one simple example, but it gives one really important principle that is not just for Kinects, it's for every sensor that you ever will learn about anything. At some point, there's a number. You can't avoid the number, right? And there's going to be a lowest number that the sensor can give you and a highest number. And usually they're not the numbers you need to control the thing you need to control, right? and you need to condition those numbers to turn them into a useful value. And that's what the limit scale value actor can do for us. We can put in a set of numbers, we measure those limits, and then we give the desired range of output, and now we've got something we can work with. And that's one thing that this little patch illustrates really well. Okay? All right, questions are coming up. Let me just stop for a moment and answer some. Trombone zoom, I'm so into that. Let's see that. Okay, so somebody has an error when they're Kinect. Like I said, I can't help you during the session, but go to the forum. We'll try and help you work it out. Question, so the OpenNI file is called through the sensor URR output. I guess it will be an input. Well, I don't, basically, there's a file name, right? You put in the file name where it says file, and then you click play, and if there's an OpenNI file at that path, it can be usually in the same folder as the Isadora file would be the clever way to do it, but you can put it anywhere if you give a full path. Although I haven't tested that yet, might not work. But anyway, it'll play the file when you hit play. It replaces the sensor. It actually shuts down the camera. It plays the file, and when you hit stop, it brings the camera back to life again, right? All right. Yes, it's possible you're looking at a different version of the OpenNI tracker. A few minutes ago, I asked everyone to install the one that is in the download, the one that the guru13.zip download that is at the top of the chat, the very, very first thing in the chat, yeah? Okay. All right. So let's go on. That's one example. Here's another one. One of the things that probably you don't want to work with so much is absolute position, because in general you want the dancer or performer to be able to move anywhere on the stage, and so usually you probably end up measuring like maybe an angle of a joint or the distance of a hand to another body part, or we're going to see that in a second. But I can imagine, especially for installation pieces where you have the public involved and you're just sort of like want to have a response based on where they are, that absolute position would be something you could use. So I'm going to show you how to do that. Let's look here at this very first. Again, this is a normal tracker, and Annie's there, and you see the skeleton, right? But let's go down here and look at this first skeleton decoder. I've chosen torso in the point select, so that's the one that I'm getting. That is, anyway, the first one. And then I'm going into a calc angle 3D, and you'll notice that I've got the X, Y, and Z connected. I've got the Z connected to the trigger, which makes the calculation happen. That's just so that every time a new number comes in, you will get a value. But then, that's kind of weird, the X, Y, Z at the top don't have anything connected to them. That's because the idea of this patch is that we are going to set some locations where a certain thing is going to happen if she's right in that location. So let's pick a spot. Maybe this time let's come closer to the camera, not too close, but just like, so she's moving there. All right, so I see where she is, and I just have to go here and look at the torso. 0.08, 0.2, minus 1.7. So 0.08, 0.2, minus 1.7. And by doing that, the distance is almost 0. Now move away from that point, and you'll see the distance is getting bigger and bigger and bigger and bigger and bigger, right? It's 2 meters now. But then we've used the limit scale value to control the fading in of a still picture. Okay, that's because this limit scale value is going to the intensity input of a projector actor. So let's do our measurement again. Can you remember where that point was actually? Yeah. Pretty close. Let me put it in. Actually, let's give you a little something to put there, so that you can come back to that spot. Okay, so we're putting something on the floor right now, so that she can. Oh, you can see how the skeleton went a little bit crazy there. So she can really find that spot again. Obviously, if you're doing something like this, having a physical object that someone might need to touch or orient themselves to would be important to make this work. But here we go. 0.1, 0.2. and minus 1.8. All right, now see this distance is almost 0, so that's our low number. Let's say make 0.1 our low value, whoops, 0.01. And now, let's see, how far away, do you, like walk away just a little bit. I'll tell you when to stop. Oh, stop, okay? So there, the distance is 1. That's 1 meter. So I'm gonna set the limit max to 1. Same thing we did before, right? We measure the minimum, we measure the maximum, because what we want to do is, when she's in that spot, we want one of those pictures to appear. So return to the spot. And let's go ahead and full screen that so we can appreciate it. So there she is on the spot, and now if she backs up, or comes back to the spot or moves left or right. Well, there's a different picture there. That's okay, though. So, but if she returns to that spot, it is always going to fade in that picture, right? And I have 2 other spots defined where a still picture will appear. Yeah, but let's say that one of them, let's make it happen. Let's see if it loses you if you sit on the couch. Go try sitting on the couch, please. Off to the one side, though. All right, the skeleton's kind of confused, but it's still giving me a number. Let's measure that for the next one. So I'm going to use that for 0.7. I'm looking at the numbers here. 0.73, minus 0.39, and minus 3.5. So I've now associated this picture here, you see this other picture, with that spot on the couch. So what I'm going to do is I'm going to move it a little bit so it's right over where she's sitting, right? Yeah? So now, if we go full screen again, once you get to try coming back to the middle. Okay, there's that one, and go back and sit on the couch again. Right? So now you could have it set up so that every time the public in an installation piece enters a certain particular area, as long as it's able to track them, it would then fade in a light or fade in a video or make a sound occur or whatever else you want to control. It can be anything, of course, and once you have those numbers, then you can do anything. But this is kind of a unique thing. Probably in a performance, this would be, I can say that in my whole career, I never did this. In my performances, I never did this idea of absolute tracking. But you can see that there's a point to it of why it would be useful. So, but the deal here is that to make this work, you have to get the person to stand in the target place, right? You take that torso XYZ and you enter it in the calc angle XYZ here at the top. Because then, if you're in that spot, the distance will be a very low number, almost 0. And then it gets bigger, of course, as you move away. And you can then use the limit scale value, just like we did before, but this time to scale it so that that image fades in or fades out, right? Okay? So that's this idea of absolute positioning, okay? Let's see. Just looking back at the chat here, there's a lot going on over there. I got to check it out. All right. I think we're all right. Let's continue. Okay. Here's one. I believe Annie said that our dear friend Gertjan had this as an idea. I don't know if that's true. But anyway, we decided to implement it here. So it lost you now. Okay, now let's see if it finds her skeleton. So as you can see, I have 2 emojis, a princess and a bunny. Yes, that's something I would probably never do in my whole life. I don't know. I was just looking for an image. And the idea of this is that this is a decision-making system, right? Because you can see that if she raises her hands high enough, the bunny turns into an ogre and the princess turns into a space alien, okay? So, I don't know. I mean, actually, probably if you were like working with kids, this could be an amazing patch. Maybe I shouldn't throw shade at the emojis, right? But in any case, it's making a decision about which emoji to show based on the relationship of the hand to the shoulder, okay? So let's see how we did that. Basically, what it comes down to, first of all, in terms of tracking it, we're just taking the XYZ of the hand, and that is going directly into a 3D projector actor, right? And that just accepts the coordinates. How did I make it fit? The key was finding the right amount of Z translate on the 3D stage orientation actor. That is critical, because watch what happens. I'm going to just go ahead, you continue moving like that, that's wonderful. Here I'm setting the Z more closer to us. So it actually still follows her, of course, but it doesn't stay in her hands anymore. And if I go back, now it also still stays in her hands. I mean, it still follows, but it doesn't stay in her hands. So for whatever reason, the way I've got it set up, 2.1 was the perfect thing to get it to stay. It's also important to say the skeleton scale is in meters, right? If it was in millimeters, this would not work. The Z translate would have to be a different number. But is it roughly the distance from her to the camera? No, not really. It's more like 3 meters. I don't know. Anyway, it worked. So that was the magic number to get it to work, right? So that part's easy. Getting it to follow her hands was pretty easy. You just take the X, Y, and Z coordinates of the hand and feed them over here to the 3D projector that moves the picture around, yeah? Okay, but then the decision-making part. You can see here that we've got the left hand Y. Remember, Y is this way, up and down, right? And we've got the left shoulder Y. So the calculation is relatively simple. If the Y of the hand is higher than the Y of the shoulder, then we want to show you the ogre or the space alien. And if it's below, we want to show you the other image, yeah? And that is all happening with this comparator right here. There's a comparator, and the top one is the Y of the hand. This should be your left hand, I think. Let's see. Well, you can see them changing. And right now, it's below the shoulder, but if you reverse it, now it just went above the shoulder, right? And you see the output of the comparator changing. So when she puts it above the other hand, there, it changes, right? So that comparator is telling us which one is higher. And then I made this little user actor. I really have been meaning to make this into a built-in actor for ages. But I actually put an explanation there for you. Suffice to say, there's lots of times when you want something when it turns on or off. If it's on, you want it to kind of go up to something, and if it's off, you want it to go down. But you don't want to trigger an envelope generator because it'll start over at the beginning. So this actor, if it's on, it counts up at the rate specified. If it goes off, it counts down at the rate specified. And that's because that is what's going into the video mixer that is mixing the two emojis, right? So we're using that up-down 0 to 100 user actor to make it so that, because also if you use an envelope generator, when you cross the threshold, the numbers are kind of flitting around. They can be weird, and you get vibrations, and you suddenly get millions of triggers. You don't want that. This actor avoids that, so that's a really handy actor to use. I use a version of this in almost lots of things that I do, right? So that's there for you, and I tried to put a comment to explain it. Let me take a quick look at the comments. I guess you can use the whole range actor if you want really accurate numbers. Yeah, but you know what? Getting it down to 100th doesn't matter. I mean, honestly, it really doesn't. I mean, because the thing is, there's so much drift and inaccuracy in this. I mean, if you were using a $100,000 Vicon system, okay, then maybe I would spend the time getting it down to 100th. So I think, yeah, you can use them. I've never done it. I just look at them and like make a guess, and because then I always end up tweaking them to make it feel good, right? I mean, measuring is one thing, but how does it feel? And sometimes you need to tighten that range to make it a little more responsive. Like if you make that limit min, limit max a bit more narrow, it's going to give a bit more pop to the way it responds, right? It's like amplifying it. So I don't know. I personally never measure, but everyone should do whatever feels right for them. Yes, of course. Everything we're doing, I mean, there is a million possibilities. John Rogers asks, instead of emojis, the left hand can control the volume of a sine wave and the right can control the frequency, right? Yes, absolutely. The thing I always say in workshops when I teach about this, I'm trying not to get hysterical seeing the princess and the emojis flying around in front of me. The thing I always say in workshops is a number is a number is a number. And when we control media, in the end, you're going to feed it some numbers, right? So anything that you can control with a number, that's something that's a candidate for being controlled through this system, right? And there's lots and lots and lots of things we can control with numbers inside of Isadora, of course, and inside of all kinds of different software that we use, right? So the answer is yes, it's absolutely possible, and you're going to see an example with sound in just a minute, right? Okay, so yeah, that's basically it. The second part of the thing is just a duplication of the first, doing exactly the same thing. It just has two of them. Obviously, if you wanted to put this on every point of the body, you'd have to do this 15 times. If you were going to do that, I would make a user actor, of course. Yeah? All right, so that's that little example. So here we're making a decision on the relative position, because that's different than the absolute. Now you can walk anywhere in the room. It doesn't matter how you're rotated or where you're facing. If that hand goes above the shoulder, it's going to do something, right? That's a decision based on a relative position of the hand in relation to the shoulder. And so it doesn't matter where you are. There's nothing about absolute information. They're saying I should give you a break. I don't know. You look like you're having an awfully good time. All right, let's go on to the next one. Okay, for this one, everyone needs to go to their live capture settings. So that's input, live capture settings. And you're going to want to turn on your internal webcam and your microphone. So here I've got it set for my FaceTime HD camera and my MacBook Pro microphone. I hit start live capture, and there's me again in the thumbnail and also my voice, but hopefully you can already see what's going on there with this, what's happening. Let's just full screen it just to enjoy that. So you can see now that there are like little Bauhaus illustrations of bubbles emanating from Annie's hands as I speak, and the volume of my voice is what controls the size of the bubbles. So here's another parameter. Here's another parameter where we take something that's a number and we control something else that's a number, which is the size of the particles as they're being generated. Yeah. Okay, so this one, I'm not going to explain particle systems. That's in another guru session, so don't worry about, go and watch that one if you want to understand particle systems. But what I do want to say is this much. We've got a skeleton decoder set to look for the left hand and the right hand, right? So left hand, left space hand, comma, left space, right space hand, right? And then I've got the XYZ of the left hand going to the XYZ inputs of this 3D particles actor, yeah? And here's a gate. That's just to make it turn on in a nice way. But basically, I've got a pulse generator over here at 10 cycles per second. Let me zoom in on that better. That's what's making the particles appear 10 times a second, yeah? And the other key element is this sound level watcher, which I've got connected down here to the object scale, horizontal and vertical. So when I am quiet, I'm never quiet, you know, it's almost zero. The particles are very small. But if I'm loud, it's getting really big, giving this kind of simulation of these bubbles. Now, to make it look a little bit nicer, I did change a couple settings. I've got that Y, the up, and the Z velocity, so set to 0.5. That means the particles are going to want to go up and a little bit towards you. And I did the same thing with the gravity, 0.5 and 0.5. That means they tend to speed up. When they have gravity, they'll speed up a little bit as they go up, right? But the point here really isn't the particle system. The point is that we can, well, it is in the sense that particle systems are something you might really want to do with a tracking system, but here we're interactively controlling it so it has a bit more life because we've got this element of our voice that's controlling how it works. All right, some questions just came up. Let me see what they say. So if you are projecting, e.g. images, when you move into a certain area, do you see the skeleton on your screen and then project? And on the projection, is it only images? Yeah, I mean, you're seeing everything together because I wanted you to see it. But here, let's just imagine that we're done with our preparation. So here, I'm just going to go to this projector actor that shows the Kinect. Now here's any without any, right? You're just seeing the things that are coming from her hands and my voice controlling them. Move a little bit slower so we can, or actually, let me speed up the pulse generator just a little bit. Will be better. So now you can see where her hands are, but you can't see her. And you can imagine that you were just projecting this image into the space and she was dancing in front of the Kinect camera. That's definitely one of the things you would do. The only reason I've been showing you this image and the skeleton inside of it is so that you can see what she's doing and what's going on, all right? Question. I tried to save the user actor to, well, I don't know. Let's find out about that later. Okay, someone has to run. All right, so good. All right, we're coming actually, I mean, this might be the shortest guru session already. It's only been an hour, and we're coming into the tail end. I'm sure you're going to have questions. I know there was one I forgot, too, about the ghost. Let me come back to the ghost, okay? So, all right, let's do one with music now. So we did this already, actually, in the other example. This is just the distance between Annie's hands, and it's controlling a sound, and you should have the sound too. And if you want to hit letter P to play the recording, you should be able to do that, and you'll actually have Annie doing it for you if you don't have a camera or whatever. But you can see here, and we did this one. I made a user actor for this that kind of embodies the whole thing. You choose the 2 points you want to measure, you set the minimum distance and the maximum, and then it gives you a scaled value that goes from 0 to 100 always. And this why is this raw distance important? The raw distance is there so that you can observe those values and set the minimum and maximum, right? So let's calibrate it right now. So put your hands at your side so that they're just on your, like, down. Okay, so that is 0.48, let's call that, 0.48. So that's when her hands are at her side, and now put them straight out like this. That's the maximum, and that's 1.67. And I saw that at the raw distance, and I've now calibrated this to give me 100 when her arms are out, and 0 when her hands are at her side. Now, I'm actually going to make it a little bit smaller than 0.48, though, because I want it to be, even if she just opens them up a little bit, I want to hear it, yeah? Okay, so here you had the question earlier about controlling sound. Here you go. This is exactly it, where we are going into the sound player, controlling the volume. But of course, if you had like a MIDI synthesizer or a MIDI synthesizer software connected, you could be sending MIDI messages or open sound control to change filters or who knows what. I mean, anything is possible once you get into here. But as a simple example, let's just take a full screen look at this for a second. You know, I mean, I actually am not, I think it's really nice, and I tried to use this kind of slightly interesting piece of music. I mean, I was whipping this together today, so it's not the best in the world. But let's try something a little more complex. Let's go to the next scene, where is it exactly the same idea, but now I'm measuring the distance. Now I'm measuring the distance between her left hand and right hand, but also her left hand to her left hip, her right hand to her right hip, and then the rotation of her hands, the angle, to control a fourth sound. Try just dancing freely for a second. Okay, beautiful, beautiful. All right, so there's nothing different about that patch and the one you saw before with just her hands. It's just that there's 4 of them instead of 1, right? But there's a couple of interesting things happened. Did you see where the skeleton got confused and the hand fell down into the body and then fell back up? And A lot of people might see that happen and be like, oh, that's terrible. Well, it is terrible. Of course, we don't want that to happen, but of course, we also are artists. We don't have millions of dollars to buy the most sophisticated motion capture systems in the world, and so we're dealing with stuff that is relatively inexpensive and does a pretty good job of tracking, right? So those flaws, you have to embrace them. And in fact, I thought it was interesting. She was making this move and it fell in. You got this accent. She also heard it and she reacted to it as a performer, right? I mean, I guess what I'm saying is you have to kind of take the attitude of that it's not a bug, it's a feature, right? And work with these things, but also what you do have to do, this is why rehearsal is so important. You will never find out the kind of stuff that will happen with these tracking systems until you rehearse with it and see that happen. And you'll know then what you might need to do about it to give a satisfactory artistic result, right? This is why rehearsal with these kinds of systems is absolutely 100% essential. You cannot skip rehearsals when you're doing this. All right. I think that you're getting the idea here, I hope. And let's move on. So here's the same thing, but with some tones of piano. I don't know. I didn't know if anybody would. That music back there, that was some of my old samples that I had for another piece. Here's a different one. All right, that's beautiful. Thank you. All right, we've got one last little patch here that I thought I'd show you. That's a great question about the second actor. I'm going to take as many questions as you want to ask. We should also give Annie a break in a moment because she's been at it for a while. So what you can see here is I've got another 3D projector, and I am going to lower the intensity a little bit so that you can see through it and see there. So what you can see there is that it's tracking Annie's hands and rotating that plane to follow whatever she's doing, right? And again, as Eva brought up earlier, probably you're not going to show this, you're not going to show that person, you're just going to show the result, right? And maybe it's on a completely different part of the stage, maybe it's on the roof. I mean, it could be anywhere, right? But the basic idea here is that we're taking her two hands, right? She's got her two hands, we're measuring all the rotations and using that to rotate, but also position, we're feeding the position of it into that so that it will find its way, right? And to do this, this goes back to that 3D puppet that I made in the other example file. I've got another variation of that JavaScript plugin here, and this one's a little bit different because the puppet expects, if my finger is the model, it expects to rotate on a point like this, right? But here we want the center of whatever she's holding to move. So this one uses the center point to position the object, not the end of the object. That's a slight difference. But the main point is, you don't have to understand JavaScript, you just need to use the actor, and if you feed in 2 points on the body, and it could be any 2 points, then this rectangle is going to rotate and follow. And I've just got this going, and you should see it too, so that the live feed from the video in watcher is feeding into that actor, right? And if I put the intensity up to 100 here, because I also, by the way, I use that other actor I mentioned, the one that counts that goes up or down depending on on/off. So here, can you walk out of the frame, please? Because it should know that she's gone, and you see it fades away nicely. And if she comes back into the frame, there it is, and it faded in, and it's tracking her, right? So I have that actor in there too. That's that up, down, 0 to 100 actor I mentioned earlier. So first, thank you so much, Annie, for performing for us. Everyone should applaud somehow. I don't know how you do fingers in the chat, but we all need to do that for Annie. Thank you for being our person today. And now I'm really happy to take, we're actually did really well. It's only an hour and 15 minutes. That's like short for these. And I'm really happy to answer any questions. Let me go back to make sure I didn't miss any. Okay. Is it a bug or a feature? Well, it's a feature. Let's just go with that. Does the beta actor identify a second Kinect camera simultaneously if you add another? No. You have to figure that out. So what happens is when you connect to the Kinect, it will show you, let me make this bigger, at the sensor URI, that's a Universal Resource Identifier, stands for, yeah. And in this case, it's freenect://0. On Windows, you'll actually get a truly unique serial number that identifies the device. On Macintosh, it's actually not as good because the order in which you plug things in could reverse things, right? But basically, you're going to see these sensor URI. Normally, if you're just working with one camera, you don't have to worry about that. But if you want to have two, then you need to enter that sensor URI into this first input. Or you can go by sensor index, which, if you plug your cameras in a very particular careful way, can also work. But basically, what you want to do is use the unique identifier of the device. And so if you have two, to make sure that they find the right one. One caveat with Mac. On Mac, they do not actually tell you the true unique serial number of the device. Instead, they kind of make this up, freenect://0. And in fact, if you plug your cameras in a different order the next time you hook them up to the computer, then it will not be the same. So probably you're going to have to plug your cameras in and make sure you do it in a particular order so that they always show up with that same number, freenect://0, right? So that's how you get two cameras working at once. As BoneMap will tell you, or if you've seen in the forum, he had 5 cameras working at the same time. I can't even believe that, but he actually did it. So it's possible that it actually can be done with a lot of cameras. He got it working. I'm still amazed by that. I would probably not be so brave, but anyway, he got it done. So that's how you do multiple cameras on the same patch. Question, is the red body a good way to measure a simple Z distance with eyes ++? Well, that's a great question. Let me go back and answer that, but let me go back to the very first scene here for a second, and I will just play the clip so that Annie can continue to have a break. So there's the red image, and in this case, you can see here, I used a chroma key actor because I need to put it so that you can have the choice of not having a background. Why did I do that? Well, if I move that out, you can see it's solid black, right? There's some options here that I think it's worth showing, yeah? So the options for the background are, you can say hide background, which is this mode, so you basically just get the one figure, which is something, yes, you can feed directly into eyes ++ or eyes. But if I say show background, then I get that background plus the red body. But the thing about that is, it's interesting, if I want to grab the red body, I just put the chroma key actor in, and I've now eliminated the background, right? Because of the way, take note of the way I have this chroma key actor set. It's set for red, the inverse is on, and the alpha is on. That is not; those are not the default settings, okay? All right, but you could easily, I can do it right now, if I take an eyes actor and I take this image, if I set it to hide background. Oh, by the way, the other mode is colorize bodies. You just turn it off. That's the pure depth image without any colorization whatsoever. But if I say hide background, I can take this directly into eyes, and you'll see if I turn on the monitor, it's totally tracking. It's totally tracking, right? So yes, that's a very, very cool idea that you can do that. Because that way, it doesn't even have to recognize the skeleton. It just has to colorize the body, and you can have up to 6 of them, right? Because that's the thing. If you wanted to do multiple bodies, You could add a chroma key color for each color body, one for green, for the 6 colors I identified at the beginning of this tutorial or that are in the tutorial file, and use those to pick out whichever body you want, right? Okay, can you show us the whole OpenNI tracker again that you have? Yes, everything that I have is the same as what you have, except this file input, play, and stop. The file is a file name for a .oni file. Let's just take a look at that. This is an addition. I did this 3 days ago, or I started working on it 3 days ago. It worked well enough that I thought I could show it to you today. No, I'm not going to put this on the forum. I only want people, well, I want people who have listened to me talk about this, using this. I'll announce it when I've got the record feature working. But if we look in Guru 13, there's 3 ONI files: walk forward, hand distance, and arm shoulder. I recorded those earlier using my version of the plugin, which has the record triggers still there. So what you have, the file name, and then play, and then stop. So if you hit play and the file is there, it'll play it. And if I hit stop, you'll see that it's actually going to go back to working with the camera, with the actual real camera, which right now there's nobody there, so we don't see anything, right? If I show the background, you'll see it there, right? So, but if I play the file, then you're going to see the file playback, right? Okay. So, but in terms of showing you the whole OpenNI tracker, I wasn't going to do every input today. I think try, remember the help is always there for you, right? If you point at these things, you point at like depth histogram, it tells you all about that, although that's one I should probably point out because it's actually important. But basically, everything that you need to know there, you can find out most of it just by pointing at it and reading the help over there. But if you have a question about a particular input that doesn't make sense to you, ask it now and I'd be very happy to entertain your question. But I was going to try and avoid just like doing a laundry list of every single input. Okay? All right. If you want Mark to see your question, please preface it with Troikatronics. Yes. Can you address the advantages of the Realsense camera with eyes? Yeah. It's pretty simple. The disadvantage is the depth image is somehow not quite as clear as what the Kinect and the Astra give you. And it somehow doesn't track bodies so well. It has a hard time finding the skeleton. But that camera can go at 90 frames a second. So in other words, the latency is 1/3 of a camera that goes at 30 frames a second, right? So this is pretty interesting that it has this high frame rate, and Isadora supports that. But of course, then you only have the depth map image to work with. You can't actually do the body tracking, or at least it doesn't work as well, unfortunately. But there are other people, like there's some people on the forum who don't use the skeleton tracking part of it. They condition the image and they put it into eyes, kind of like what you just saw me do here using the body tracking. But so yeah, I think that's the main advantage, is it has some really high frame rates, which if you want a very low latency tracking is possible. Also, it uses a slightly different technology, and I don't even have proof on this, but I think the range might be a little bit better than the Kinect, perhaps. Yeah. So those are a couple of points. I think I sort of pointed this out in the written documentation for the tutorial that I gave you earlier. But yeah, only a few people have them. I have one. But if you, there's some people in the forum that have them. We can open a discussion about this to get more deeply into it. Yeah. Okay. Okay. My JavaScript actor has an error message, error line 1. Oh, well, that's not very nice. Okay. Does anybody else have that? Please confirm if you're seeing that. How would you send the skeleton tracker data output to another Isadora computer over a network? Well, it would be nice to have a built-in actor to kind of do that for you, because it's so many numbers. I guess we could have a discussion about that. Right now, the only way you could do it would be to have, I would use an OSC multi-transmit, right? So I would use Open Sound Control, right? So here's an awesome multi-transmit actor where we can add 15 whatever outputs, and I would just take my skeleton decoder and just start connecting them up, right? So that you've got an output for everything that you need there, yeah? And then you can use an OS listener to get the data on the other end, I think. But I think if it's I can see right now, especially with remote performance and this whole thing, I can see this being something we should investigate. Maybe we need a way to broadcast this data, right? And also, yeah, I have a heap of ONI files recorded with NIMate. I assume they will play through Isadora. Good question. I have no idea. I'm using like the totally built-in system to record those files. So in theory, yes. Please let us know if that is true. I'm curious if it really works. Let's find out, all right? I would assume it would, because I'm not doing anything besides saying record the file, and that's why I was disappointed that it worked really perfectly, recording, playback, everything on Mac. On Windows, if I play the file and try to do body tracking, it crashes. I don't know why. So, okay. Okay. That's all the questions so far. So, you know, I'm going to talk for just a minute more to give you this is your chance if you want to know. Oh, let me cover the thing I was saying about the histogram thing. That is actually important. So let's set this to no colorization, right? Actually, Annie, I need you back for just 1 second for this. For this, I got to do it live. Okay. So I don't even know if we can actually demonstrate this perfectly. Let me try it with this. I need to put a chair here. Okay. So as you can see, if you can look at that image, let me move the stage here. As you can see, the chair that I just placed near Annie is a little bit brighter than Annie. That's because Annie is in fact behind it. But if she walks forward, did you see the chair get darker? Walk back. So the chair is changing brightness because she's getting closer and she's filling up more area, which is very much like an automatic gain control on a camera, right? That's it. That was perfect. It's an automatic gain control on a camera. So for looking at the image, it's actually nice. It gives a little bit more depth to the picture. But if you want to use this to do tracking with eyes, then this is not helpful, because you might want to have it so that only a certain zone of brightness, meaning remember, brightness is how close or far away you are from the camera, so that you might want to only deal with that part. For example, just using that chair, I'm not even going to have any back, but I'm going to use a luminance key actor, right? That allows us to filter out things that are brighter than or less than a certain brightness, right? So if I take these output here, and well, actually, I won't even do it with the eyes yet. Let me just do it with the projector so you can see. So here, I'm going through the luminance key, and I'm going to take, now see if I do the key top, that means if I go with a certain spot, the whiter stuff disappears. Well, I want to keep that chair, but I want everything behind the chair, which should be darker, to disappear, right? So if I do this, I can kind of do that, right? I mean, not the floor, but everything else. The problem is, if you use that technique to isolate a certain range of depth, and it's changing the brightness of stuff, it won't work, right? So if I go in here and I change this, though, where I say depth histogram off, now it will not change the brightness like that anymore. It will stay consistent. And so now if I get it zeroed in on this chair, can I have you back for just 1 more second? I've just got a width just as wide as the chair, or actually let me try and make it so that we can't see Annie if she stands behind the chair. There, we can't see you anymore, but if she walks forward, she's in that zone where we can see her, and if she continues to walk forward, she disappears again because we've set the top and the bottom of the luminance key. Thank you. So that's how you could condition the image, and then you could feed that right into eyes and be using that so that people that are only in a very specific depth range are tracked. But if you're going to do that and use the luminance key, you must turn the depth histogram off so that you do not have that automatic gain control. Okay? Okay. Any chance that we can get the recording tool for the Rococo suits as well? I would absolutely be happy to do that. I want to do everything. I just can't. There's only one of me. That's the only problem. But yes, I would like to do one of everything. Yes, I think it's possible, Jurian. You know how it is. Just a lot of things on the plate. I second that motion. Are you seconding the motion of the Rococo recording system? Okay. And all right. No more additional questions beyond that. All right. Well, maybe that's a good place to stop. We actually made it in an hour and a half. I mean, in the end, it's always an hour and a half. Oh, well, let's have Annie back. Hold on. Let's do it where we can really see you. Actually, I think we should have. Really, I don't know what I was thinking with the emojis. I should have really had them. I should have really had them be cats, because then it would be cats on the internet. We'd have the most popular video we've ever had, probably. But anyway, now she's making princesses and bunnies and ogres and aliens, right? So I think that was a pretty good session. I was actually really nervous about getting this done today, and I was so really nervous about giving you the alpha of the play thing. It seems like it's working, which is really great, right? So, so I thank you for coming. The usual spiel. Please subscribe. Please tell people about Isadora. Please join us in the forum on the thread for this post, which I will put in the description of this, but I think you know where to find it. If you have questions or specifics that you want to get into, and check in this week. I'm the whole next week. I will be focused, my programming will be focused on getting this record function done and getting the Kinect 2 working. Oh, important last question. Someone asked earlier about, can you give us a session about the Kinect 2? Well, there's nothing to get. It's exactly what I just told you, because it all works exactly the same way. Because in this version of the plugin, we're just going to support this kind of tracking. Now, the Kinect 2 supports actually much more, but only on Windows. So we are in discussions about, if it becomes really important, we will make a special plugin just for Windows that offers those additional features that the Kinect 2 offers you. But the thing is, it will not be cross-platform, because there is no way to replicate those additional features on Mac OS, right? Okay. Would you have a good hint keyword where to start digging for a fast way to transmit data, just numbers, to another computer via the internet? I think WebSockets is the way to go, but I don't know enough about it to say. This came up recently that one of our users, our top users, said we ought to be able to supporting WebSockets for sending numbers. That is something also that I am going to actively investigate, because it pertains directly to remote performance. So that's what I know off the top of my head, but others may have other ideas. So please check in the forum, because I am not the smartest person here. There's a lot of smart people in our forum as well. Okay, there's one more. Yeah, okay, I think we did it. Let's continue in the forum. I'm so glad that went well. I was actually super nervous, like I said. It's always so great to see all of you here, and I hope that some of the ideas in this file about doing something beautiful with this will inspire you to take Isadora and use this tracking stuff to make something beautiful. I think that it was interesting that I was watching all day Annie moving in isolation by herself in these images, and I was kind of like moved by that in a way, because even in this recording she was sort of alone. And so I don't know, I think there's some things that we can use this technology to talk about, and let's see what we can do to talk about the time in which we live with this. Anyway, there you go, bunnies and princesses and ogres and aliens. And so I hope that I will see you again very soon. Thanks a lot for coming, and see you at the next Guru session.